Hello viewers, welcome back. In the last lecture we discussed some problems based on SN1 and SN2 reactions. Here we selected a few more problems. As I told you, the students mostly get confused if some of the reactants as given, which pathway it should proceed, whether by SN2, SN1 or E2 or E1. So please remember that whenever the reaction is given, here we have to observe very carefully what type of or what nature of alkyl halide it is and the nature of nucleophile and the leaving group. Sometimes solvent and temperature. Okay, these are the main points we should consider. Let's go into the problem. And this is the first problem. So this is the one. Tertiary alkyl halide. Okay, so this is the tertiary alkyl halide and this is the strong base. Okay, so as we know, the tertiary alkyl halide, it will not undergo SN2 reactions, so there may be a possibility of SN1 or E2 or E1, but you see here this is a strong base and this can mainly help to go forward for E2 reaction. Okay, so as we know, it will take the proton from the beta carbon. Okay, so this is the beta hydrogen. Halogen connected carbon is a alpha carbon and this is a beta carbon. So this nucleophile, it acts as a base and this will abstract this proton and it come like this and it go by this way, and finally we will get by this way. Okay, so like this we will get it. So this is by E2 mechanism. What about here? Almost the same. Actually this is the same alkyl halide. So this is also tertiary, but here this base is more bulkier. So this is an alpha carbon and this is a beta carbon. So please remember that whenever this bulkier basis comes, so it will try to abstract a proton from the least hindered beta carbon, for example like this. So this is the beta carbon and it will abstract this hydrogen, the beta hydrogen, from the least hindered, and it will come like this and it go by this way. So we will get by like this. So and this is the one we will get. So this is the least substituted alkene we will get. Okay, and this also followed by E2 mechanism. Okay, so this is the main difference. This is the bulkier, this is not a bulkier base, but this is a bulkier base, and this is a strong base, but it will abstract from the beta hydrogen, which is gives the Setsev product. Okay, in this condition. So these are the main difference we can observe from the base. And what about here? So this is the secondary alkyl halide, but this is the fluorine, but this is not a good leaving group, so no reaction will occur. Okay. What about this one? So this is the secondary alkyl halide, but the base is here, the nucleophile is weak, so it will undergo by SN1 mechanism, but this is a chiral, so we will get mixture. Okay, then we will get the racemic mixture like this. Okay, this is the hydrogen and this is the ethyl, and one is the OH here and another this side. Okay, and this is the methyl. So we will get 50-50%, and this reaction proceeds by SN1 mechanism. So this we already discussed in the SN1 reactions, the stereochemistry. So whenever it is a chiral, it forms a carbocation, and followed by the nucleophile will attack on the both sides. Okay, that's why we are getting two mixtures. Okay, these racemic mixtures, these are optically inactive. Okay, if you want to learn more about the stereochemistry of the SN1 and SN2 reactions that I given in the description link, please go through that. Here, this is the secondary alkyl halide, and this is the one soda amide. So this can act as a base also and a nucleophile. So we can get both products. So we can get both products like a substitution product and elimination product also. Both are possible. Okay, so this is the SN2 product and this is the E2 product. Okay, so this is the primary alkyl halide, but this is a bulkier base. So what it will do? So this is an alpha carbon and this is a beta carbon. So this will abstract the proton from the beta carbon and it come like this, and this halogen will get depart. So finally we will get like this. So this is by E2 mechanism. Okay, because this is a bulkier base, so it creates a lot of steric hindrance, so it will undergo by E2 mechanism. And this is the secondary alkyl halide. The cyanide here acts as a good nucleophile. So here this is the chiral one, that also we should remember very carefully. So whenever the SN2 reactions takes place at the chiral center, it will give inversion of configuration. Okay, so we will get like this, and this is CH3, and we will get the inversion of configuration. Okay, this is by SN2 mechanism. What about this one? So this is a one secondary alkyl halide, but this is a poor nucleophile. So this will undergo by SN1 mechanism. So first this will get cleaved and this will form a carbocation, and this is the secondary carbocation, and at the same time this chiral also. Okay, but here this one, there is a possibility of hydride shift here, and it will give tertiary carbocation. So like this. Now this is a tertiary carbocation. Now this is more stable, and this is the secondary carbocation. This is a tertiary carbocation. Now this methanol, this nucleophile, will come and attack like this. Finally we will get the ether like this. Finally by this way, this is OCH3. Okay, I hope you understand this problem session. Please remember that whenever you are going to start the this problem, observe it carefully, the nature of alkyl halide, the nature of the nucleophile and the leaving group. So accordingly we have to decide this which pathway. Okay, I hope you understand this session. Kindly subscribe and share this video if you feel this lecture is useful. Thank you.